Hi everyone, welcome to a redo of our lesson 3. So in this lesson we are going to use exponents to name place value units and explain patterns in the placement of the decimal point. All right, so just to do a little review of what we did in class today. So if you haven't filled this out, go ahead and take it out. It should be on page 25 of your Eureka book. If not, I have also posted it on Schoology. I have also sent it out through an email if I'm getting the information out to you that way. So let's go ahead and get started. So we're going to go ahead and start with our place. So this is also a place value chart, even though we don't have the ones place. So we're going to go ahead and start off in the tens place. So here we have the value of 10. And how many factors of tens do we need to get a 10? Just one, right? Okay, so let's go ahead and move on to the hundreds. How many factors of 10 do we need in order to get 100? So we need 1 and 2, right? Now we're going to go ahead and go to the thousands. How many factors of 10 do we need in order to get 1,000? We need 1, 2, and 3. All right. Now, how many factors of 10 do we need to get 10,000? Are you kind of starting to see the pattern? We have 2 zeros here, so that we need 2 factors of 10. We have 3 zeros here, so we need 3 factors of 10. So here we would need, I'm going to go ahead and organize these just to make it a little neater, so read it a little bit neater. We need 1, 2, 3, 4 factors of 10 to make 10,000. All right, so let's go ahead and go to 100,000. So how many factors of 10 do I need to make 100,000? All right, we need 1, 2, 3, 4, 5. And again, I'm putting these in a neat one just to remind me that 10 times 10 times 10 is 100,000. All right, and last but not least, how many factors of 10, how many times do we multiply 10 in order to get 1 million? Okay, so here we have 1, 2, 3, 4, 5, 6. We need 6 tens in order to make 1 million. All right, very good, everyone. So now we are going to use this pattern to help us with exponents. Now, I want you to go ahead and write exponent at the top of your sheet. Exponent, we use an exponent to represent how many times we use 10 as a factor. Represents the number of times we use 10 as a factor. And I'll go ahead and also put it nice and neat in the video. Okay, so let's start off with 10. Let's start off with the easy one. How many factors of 10 do we need to make 10? We just need 1, right? Or it could also be written as just plain 10. How many factors of 10 do we need to make 100? And we said before it was 2. So this way, when we write an exponent, it would be 10 to the power of 2. All right, because it also means that we're going to multiply 10 2 times. Okay. All right. So now we have 1,000. What exponent am I going to write to make that'll represent 1,000. All right, 3, do you kind of see the pattern? And also another pattern that I want you to think of, look at the numbers, look at the number of zeros that are in 1,000 and look at the number of, and look at the exponent. Is there a relationship? Are they the same? Yes, they're the same. So in 1,000 we have 1, 2, 3 zeros. And so we would need 10 3 times. And so when we write it in as an exponent, it would be 10 to the power to the third power, or 10 to the power of 3. All right, how about 10,000? How many times do we need 10? We need it 4 times, or to the 4th power. Okay. Now, how many times do we need to make? To factor? How many 10s do we need, or how many factors of 10 do we need in order to make 100,000? Excellent, very good. All right, and last but not least, you should have 6, because it not only has 6 zeros, 1 million had 6 zeros, but you are multiplying 10, 1, 2, 3, 4, 5, 6 times. So the way that you laid it out, the way that you read it, let's say it would be 10 to the 7th power. It means you would multiply 10 7 times. Go ahead and did that to kind of simplify. And I group my multiplications like this because I just like to have them in neat little groups like that. If it were 10 to the 8th power, or 10 to the 8th to the power of 8, then it would be you know, you would have 10 8 times. All right, everybody, so let's go ahead and continue with our math problem. So I have an exponent here, 10 with an exponent. Now I am going to go ahead and write this into standard form. So I know that since I have my exponent is 5, I'm going to write 10, or I'm going to multiply 10 5 times. Okay. So now what is my total? I count the number of 10s, 1, 2, 3, 4, 5. I go ahead and use my chart really quick. So 10 to the 5th power should be 100,000. And this is also another trick that I use for figures like this. So I write the zeros first, 1, 2, 3, 4, 5. Make sure you draw your comma in there, and then I write the 1 or the 2 or what have you. So now I know that 10 to the 5th power is 100,000. All right, so let's go ahead and continue with our second problem. Now this is the part that I did not get to do in class, so if you need to rewatch it again, just go ahead and rewatch it as many times as you can. So let's go ahead and start with this first problem right here. So compare these expressions to the ones we've already talked about. So these have factors other than 10, right? We've been working with just 10s, but now we're going to explore a little bit into numbers that are not 10. So the first thing that we're going to do is we're going to write 3 times 10 to the 2nd power without using an exponent. Okay, so there's a couple of ways that you can do this. So for number 1, we will write it as 10 times what? Do you remember what 10 to the 2nd power is? And you can go ahead and use your chart as well. So 10 to the 2nd power is 100, and 100 has 2 zeros in it. So 100, pretty easy. And so with some of the multiplication that we've been doing in the past couple of weeks, we know that 3 times 100 is 300. So now let's go ahead and go to problem 2. Problem 2 is a little bit different, right? Let's try 3.4 times 10 to the power of 3. All right, so honestly, this is something like this is like what we've been doing before, except we have exponents now. We don't have like 100, we don't have 1,000, we don't have 10,000 and things like that. So the first step that we need to do is that we need to multiply. We need to make this exponent into a number, and we need to figure out the product. We need to figure out how to write it in standard form. So our first step is going to be to figure out what 10 to the power of 3 is. So one quick way is to write my 1, and then since I have 10 multiplied 3 times, I'm going to have 1, 2, 3 zeros. Now I can go ahead and continue the rest. This should look very familiar. This should look like something we have done before. So now I know that I'm going to shift my number 3.4 1, 2, 3 times, right? So I'm going to go ahead and use my board right here. So we have 3.4, and then we're going to shift it over 3 times because we're multiplying it by 1,000. All right, so my 3 is actually now a, go ahead and expand this. My 3 is actually now it shifted over 3 times, 1, 2, 3. So now it is a 3,000. My 4 shifts over from the 10th place 1, 2, 3 spots, and it follows right behind the 3. And in these spaces, I'm not going to leave it blank. I need to put a 0 in there, because even though we don't have zeros here, we still need to represent the value. Okay, so now our new number is 3,400. So we know that 3.4 times 10 to the third equals 3.4 times 1,000, which also equals 3,400. All right, everybody, so we are going to go to the division side of our problems today. So we are first going to divide 700 divided by 10 to the second power. So here we need to make sure that we write, we don't have this exponent anymore. So how do we do that, you might ask? The same thing that we did when we multiplied. We know that 10 to the second is 10 times 10, which is 100. And another way to remember it is that 100 has 2 zeros. We put the zeros first, 1, 2, and then the 1. Okay, so we are going, this is going to be easy. We are going to divide 700 by 100. So our first step is going to be, I'm going to use our place value chart again. Right, 700. Really, this is the same thing that we've been doing yesterday with shifting over to the right for dividing and shifting over to the left with multiplying. So we are going to, since we are dividing by 100, how many places are we going to shift over? We are going to shift over to the right. We're going to shift over 2 to the right because 100 has 2 zeros, and it also is 100 times less. So 7 actually goes to to the ones place, and boom, there is our answer. So 700 divided by 100 is 7. All right, easy, easy. Okay, so now we're going to go ahead and do the next problem. The next problem is going to be a little bit different, but it's honestly the same thing. The big difference is that we have an exponent now. So our next problem is going to be 7.1 divided by 110 to the second. There I go again, trying to get a little bit ahead of myself. So now we want to write this so that we don't have that exponent anymore. So we rewrite it. And we remember that 10 to the second power is 100, otherwise known as 10 times 10. Okay, so now we use our board, and I'm going to go ahead and do it right here. 7.1. A little bit higher. 7.1. So since we are dividing by 100, are we going to shift left or are we going to shift right? We are going to shift right. And how many spaces? 2, because 100 has 2 place values. And we also, another big hint is that our exponent was 2. So that's why we're going to shift over 2. All right, so we're going to start with the 7. I like starting with a bigger number first. So I'm going to shift it over 1 2 times. So my 7 is now in the tens place, and my 1 is going to be in the it's going to be in the thousands place, and the 7 is going to be in the hundredths place. Sorry, everyone. All right, so my answer is actually 7.1 divided by 100 is 71 thousandths. Okay, and make sure that you are also writing a 0 when there's a space left. You write it when there's a space left here, but you also write it when there's a space left here as well. Otherwise, you would get a completely different answer. Okay, so the next thing I wanted to go over fairly quickly, this part we didn't have time to go over either, but is looking for patterns. So we're going to take a couple, I'm actually going to pull these from your homework. No, I'm going to pull them from the problem set. So we're going to take a look at a couple numbers, and then we are going to complete the pattern. So we're going to start with 3 hundredths, 3 tenths, something, 30, something, and something. I might actually do this as a quiz or something. All right, so we need to find the missing numbers. First of all, we need to look at the patterns, right? So what do we notice between this number and this number? Right, the number is shifting over to the right, which means we are multiplying each one by 10. Okay, so as you notice, it doesn't shift right, it shifts left. So my 3 actually, if I multiply by 10, it's a 3/10. And if I multiply 3 tenths by 10, that should be just a 3. And then this should be a little bit easier just because we're used to it more. 30 times 10 is 300. And that is 3,000. And then we stop there. I mean, we could go on and on forever, but we are not. Okay, let's go ahead and try another one. Let's go ahead and try one that goes backwards. So we have this blank one, 9,430, blank, 94.3, and 943. And a blank one. Okay, so we don't get a lot of hints as to what's going on here. So I'm just going to take a look at these numbers, because with patterns, the rule has to be that if it happens here, it's going to happen here, it's going to happen here, it's going to happen here. It's going to happen to all of them. So my next one, I'm going to take a look at these. So let's take a look. it looks like the number is shifting over to the right, right? Because the 4 used to be in the ones place, but now it's in the tens place. So I can easily fill this out. I know that the 9 is going to shift over to the right, so that my number is going to be 943 thousandths. All right, so now we can work backwards, right? Even though if we go this way, we're dividing, but if we go this way, we are multiplying. So I know that 94.3 times 10 is going to be 943. And 9,430, if I go this way, is going to be, I can start off with the zeros because I'm honestly adding another 0. 3, 4, 9, and make sure you add the commas as well. So this would be 94,300. Okay, there was one problem that I wanted to go over. This one is in the homework. This one is in question 3 in the homework. So I wanted to go over this one because it's a little bit different than the other ones. Oops. Million. And then maybe I should not do that for now. 34,000 blank 3.4 and then blank. So it's going to go in this order. All right, so let's take a look at these two numbers. I always want to look at the two numbers that are next to each other to just see what the relationship is. So here we have 3,400,000 and it jumps over to 34,000. As you can see, if you were dividing by 10, it would actually be 340,000, but it is not. It is 34,000. So that means you are dividing by something that is bigger. So if it's not 10, remember, because we're dividing by tens. So if it's not 10 and 1 to the power of 1, it's got to be 10 to the power of 2, right? So that means we are dividing all of these numbers by 10 to the power of 2, otherwise known as 100. Okay, so now let's take a look at the next number. So that means I am going to shift the number over, and I'm just going to cross off the zeros because I know that's going to help me shift. So instead of 34,000, now it's 340. Now I can't cross anything here, but I know that I'm going to shift over 2, 1, 2, so that it gives me 3.4 or 3 4/10. And then I know I'm going to shift over again, so I can just go ahead and write it on my board. I know that I'm going to shift it 1, 2. No, the other way. Sorry, I shifted left. 1, 2. So I know I start off with a 0. 34 thousandths. All right, everybody. I hope that was a little clear. This is one of the few ones that's going to be really hard. So this was pulled directly from your homework. It was chapter, go ahead and give you a look. Lesson 3, lesson 3, problem 3, and B. Okay. And if you would like to try these, that's good. It just gives you something else to practice. But we will definitely be going over it this week, sometime this week. All right, everyone. So that is it for me today. I will see you in class.